Today we move towards the concept of elementary operations or transformations of a matrix. So here is there are three elementary row operations or elementary column operations. First one is the interchange of row operations or column operations. I will give the one of the example for this. How can you interchange of any two rows or any interchange of two rows or columns like that? For example, A is one of the matrix 2, 3, 4, 5. If you interchange one of the rows to another rows. Here this one is the R1, that is this is an R1 and this is an R2. If you interchange this, it becomes 4, 5, 2, 3. So we can write R1 changes to R2. So we interchange. So this is one of the operation. We can interchange. By interchanging, we find out the one of the step here only. So next, now we take the second one elementary operation, that is multiplication of the elements of a row or column by non-zero numbers. So we take B is like this 0, 1, 2, minus 1. This is a matrix of 2 cross 2 order 2 cross 2. We can change the second row. I think second row. I will take this one. R2 can change by multiplying the second row elements by 2. So you can write like this 2 into R2 like this. So it becomes B becomes what? 0, 1 is as it is in the first row, and in the second row R2 is here is the 2 becomes 2 into 0, or we change 2 into 1 like this. 2 into 2. So it becomes 4. In the place of 2, we write 2. Similarly, in the place of minus 1 into 2 is minus 2. This is the second elementary operation, that is multiplication of the elements of a row or columns. I will take only the rows here. It changes, it can be made in the columns also. So of a rows or columns by non-zero elements. Zero elements ಇಲ್ಲಿ ಆಗಿರಬಾರ್ದು. Next we come to the third elementary operation, that is addition to the elements of a row or columns, the corresponding elements of any other rows or columns multiplied by a non-zero numbers. That is the second one. I will take one of the example for here. This one, A is equal to minus 1, 3, 2 and 0. Here we can, this is the first row and this is the second row. We can change the first row like this, R1 plus, or we take the minus, plus or we take the minus of I will take one of the non-zero elements, that is minus 3. I will take minus 3 into R2 like this. Addition to the elements of rows or columns, the corresponding elements of any other rows. So it becomes what? R1 minus 3 R2 like this, minus 3 R2. Otherwise directly we take R1 minus 3 R2. So here we change the row. R1 changes like this, or in the R1 minus 1 and 3 are the elements. Minus 1 changes. So minus 1 changes to minus 1 minus of 3 R2, or in R2 is the 2 is the elements in R2. So it becomes -1, -6, that is -7. So in the here is the -7. Second row is as it is. There is no change in the second row elements. The first row elements are changes because R1 changes like this. R1 changes like this. So 3 is how much? 3 minus 3 into 0. So 3 changes to 3. It becomes as it is. So this is the third elementary operations. By using these 3 elementary operations, we can find out the inverse of a matrix. 2 marks question is there in our board examination question paper. Find inverse of a matrix by using elementary operations. Compulsory question. This is the compulsory questions. I will take the steps for here. Inverse of a matrix by using elementary operations. By using elementary operations. That is like this. In the first step, I will take here is the row operations only. We can take column operations also. So in the row operations, A, the given matrix A can be written as A into I into A. For the row operation, I into A for the row operations. If we want to do the column operations, we write A is equal to A into I. This is for column operation. We can make any operation, column operation or row operation. This is for row operation. This is for row operation. So right, substitute the value of A. So I will take this one matrix -1, 3, 2, 0. So I is what? I is the identity matrix. Identity matrix of the same order of A. So 1, 0, 0, 1 is the identity matrix into A. So this is the second step. And the next steps are taking these 3 elementary operations, we find out inverse of matrix. So this -1 becomes 1 and 3 becomes 0, 2 becomes 0, 0 becomes 1. So this one, so I is equal to A inverse into A. I is equal to A inverse into A. So this is the last step. This A converted as I, this I converted as A inverse, changes as A inverse. This is the A inverse given matrix. So next we move towards the how to find out the inverse of matrix by using examples. Next we go to the one of the problem about how to find out inverse of given matrix by using elementary operations. Here is the one of the question. By using elementary operations, find inverse of this matrix. In the solution, I will take, this is the matrix 2, 3, 5, 7. So first step is what? I will write A is equal to I into A. I into A. Substitute the value matrix 2, 3, 5, 7. And I is identity matrix of the same order of A. So right here is the A. We want to change this 2 as 1, 3 as 0, 5 as 0, 7 as 1. We want to change. In the last explanation, I will change R1 first step, next R2, next R2 and next R1. This is the way to change these elements as a identity element. So first 2 changes 1. How can you change 2 to look here, I explain this here. This is R1, row R1. I take row operation, so we take elements of row. R1 changes to how much? 3R1 minus R2, like this. 3R1 minus R2. Here is substitute value 2. 2, how can you change 2? 3 into 2 minus 5. That is 6 minus 5 is 1. So this implies, here is, look at the first row is only changes. First elements of first row is only changes. Second row is as it is. Second row is as it is. 0, 1. Here is the second row is as it is. So this 2 becomes 1 by the elementary operations. Next we comes to the second one, 3. 3, how is changed? 3 changes to 3 into 3 minus, here is the 7 is there, 7. So it becomes 9 minus 7, that is equal to 2. 9 minus 7, 2. Not only this matrix, we can also change the elements of first row in the identity elements. So it becomes, so look here, 1, here is the 1. 1 changes to 3 into 1 minus, here is the 0. R2 element is 0. So 3 minus 0 is 3. So it becomes 3. Next, 0. 0, how can you change? 0 changes to 3 into 0 minus 1. So that is minus 1. Is it correct? Here is, this is over. Next we come to the R2. R2, 5 changes to 0. 5 changes to 0. How can it changes? 5 can. R2 minus this one, 5 into R1. 5 into R1. Here is the 1. 5 into 1 is 5. 5 minus 5 is 0. It becomes, we concentrate about that element. So here we want to changes to R2. So R1 is as it is. R1 is as it is. R2 elements are changes for both the matrices. So R2, how can you, R2 is 5 is there. 5 changes to 5 minus 5 into 1. That is 5 minus 5 is equal to 0. So this becomes 0. Next we move towards the 7. 7 changes to 7 minus 5 into R1 is, here is the 2. It becomes 7 minus 10, that is equal to minus 3. Right, minus 3. Next comes to this matrix, 0. 0 changes to 0. How can it changes? 0 changes to 0. R2 only 0 is there. So minus 5 into 3. That is 0 minus 15 is minus 15. Right, minus 15. And 1 is there here. 1 is there. So 1 changes to 1 minus 5 into, in the R1 minus 1 is there, like this. That is 1 minus of minus is plus, 5 into 1 is 5, that is equal to 6. Here is the 6. So here R2 is also over. We come to the next one. This point, this R2. Next, R2. How can you change R2? Here minus 3 is there. Minus 3. Minus 3 becomes 1. Means minus 3 divided by minus 3 is also 1. So here R2 divided by minus 3. R2 divided by minus 3. So here R2 is minus 3. Minus 3 divided by minus 3 is equal to 1. So next R1 is as it is. R1 is as it is. So 0 divided by, first one 0 divided by minus, anything is 0, so this one is 0. Minus 3 becomes 1. So here 15, we take 15, minus 15 is changes to minus 15 divided by minus 3, that is 5. So write 5. Next 6 becomes 6 divided by minus 3, that is equal to minus 2, right? Minus 2. This is over. Next we come to R1. So how can you change the R1? Next R1 changes to. R1 changes to 1, 0 and 1 is already over. 2 becomes 0. How can you? This R1 changes to R1 minus, here is the 1. 2 into 1 is 2. 2 minus 2 is 0. So 2 into R2. 2 into R2. We only concentrate this A. We only concentrate this A. So R1, we come to R1. 1. First 1 becomes 2. 1 minus 2 into the R2, 0 is there. So 2 into 0 is 0. 1 minus 0, that is 1. So that's. So next step is on this R1 changes. So it becomes second R2 is as it is. 5 minus 2 here. R2 is as it is. A, we must write this A. So this one already show this 1 and 2. 2 minus 2 into this one, that is 2 minus 2 is equal to 0. So this becomes 0. Next, for this matrix, first row 3 is there. 3 minus 2 into R2 is 5. So 3 minus 10, that is equal to minus 7. Right, minus 7. And we come to minus 1 next. Last element of this operation. Minus 1 tends to minus 1 minus 2 into minus 2. Minus 2 of the second row element. So minus 1 becomes minus 1 plus 4, that is equal to 3. Right, 3. So here is the I. This one is I. How can you get the I? A into A inverse. A into A inverse, or A inverse into A is also I. So this one is, this implies, what is A inverse? A inverse is equal to, what? Minus 7, 3, 5 and minus 2. That's all.